Okay, so this is 13.2 continued. So to show that the limit does not exist at x0, y0, we must find two different paths that give different answers as we approach x0, y0. So let's look at an example here. Okay, so first example, show the limit does not exist at a. So this is from practice quiz 4, it's number 3. So it's saying the limit xy goes to 0, 0 of sine of xy over x squared plus y squared. When you show this limit does not exist. So in the last example we did in practice quiz 4, number 2, we used the epsilon delta definition to prove that a limit did exist. So when you prove things using the epsilon delta definition, it's like you're proving it for all different paths coming into the x0, y0. So therefore, we could not prove it using epsilon delta because we're showing it does not exist. So our job is to come up with two different paths that give us two different answers. So let's consider path 1 here. Say, let's come along the y-axis, path 1. So path 1, I'm going to be coming into 0, 0 along the y-axis. So along the y-axis, x is 0. So I'll put here x is 0. So basically going to go over to our limit now and put 0 in place of x and then take limit. So let's do that. Okay, so the limit along path 1, so we're going to choose x being 0 and our limit up here. So I'm going to put 0 in place of x here and here. So then it will be limit y goes to 0. So putting 0 in place of x, it will be 0y. Down at the bottom here, it will be 0 squared plus y squared. And it's going to be sine of 0. But the sine of 0 is 0. So let me write over here. Okay, so sine of 0 is 0. So it'll be 0 over y squared, limit y goes to 0. Well, that's just going to be 0. So we get 0 coming along path 1. Now, we could try along the x-axis. That's when y is 0, but if you look at this, you can see it'll be the same answer. So it will not give us a different answer along that path. So let's try a different one. So let's try, say, along the line y equals x. Let's do path 2 here. So here's path 2. So I'm going to come in to 0, 0 along the line y equals x. So it'll be y equals x here. Okay, so let's look at the limit along that path now. So then the limit along path 2 would be x equals y. So it's going to, so just be limit x goes to 0. In place of y, I'm just going to replace the y with an x. So it'll be x times x, and it'll be y squared here. So if you try and evaluate now at 0, you'll have sine of 0 over 0. It'll be sine of 0 over 0, but sine of 0 is 0, so it'll be 0 over 0. This is an indeterminate form, so we can then apply L'Hopital's rule. So let's apply L'Hopital's rule. So applying L'Hopital's rule, I can pretty much take the derivative of top, derivative of bottom, and then take the limit again. So let me write this as x squared here. Let me change this here to x squared. Okay, so let's take derivative of top and derivative of bottom. So doing that, we get, well, I'll do the bottom in a second. The derivative of top would be derivative of the outer function, so it'll be cosine. Then multiply by derivative of the inner function. So derivative of x squared is 2x. So I'm pretty much using the chain rule here. And x squared plus x squared is 2x squared. So it's 2x squared. So taking derivative of 2x squared to become 4x. Okay, so coming back over here, the 2x cross off of this will become a 2 here. And now I can take limit as x goes to 0. So putting 0 in place of x here, we'll have cosine of 0 over 2. So I get cosine of 0 over 2, but the cosine of 0 is 1, so this becomes 1/2. So we got 1/2 for this limit. But that's different from the limit of path 1, which was 0. So we got two different answers coming in from two different paths. So we can say hence limit does not exist. So hence limit does not exist. So again, because along path 2, so along this path we got 1/2 as our answer. Along this path we got 0 as the answer. They're not the same. For the limit to exist, the answer should be the same no matter what path you come in along. So in this case we got two different answers, so limit does not exist. Okay, so let's look at another example, but let me erase a few things here and we'll look at part B, so another example. Okay, so part B, so we need to show this limit does not exist also. So limit xy goes to 1 minus 2 of 2 times x minus 1 squared plus 8 y plus 2 divided by 3 x minus 1 squared plus y plus 2. So we have to come up with two different paths that have two different answers. So I'm going to first come along a path that's parallel to the x-axis. Let me draw it here. So here's my first path. So the center of the circle now is, it's not 0, 0 this time, it's going to be 1 minus 2. So we're coming in along here. This is not the x-axis. The x-axis will be down here. So, actually be up here. But it's parallel to the x-axis. So in particular, the y value is minus 2. So let me write it here. Y is minus 2. For this path here, that'd be the equation of the line y equals minus 2. Okay, so let's find a limit along this path. Okay, so limit along path 1, that's when y is minus 2. So I'm going to go up here and place a y. I'm going to write minus 2 everywhere. And x then will be going to 1. So the limit x goes to 1. Then replace the y's with minus 2, so here, and replace that with minus 2 here. Well, that's 0 there, and that's 0 there. So let's write it over here again. So we get this then, and then the x minus 2 squares will cross off. So doing that, it looks like we'll just get 2/3 as our answer. Okay, so we get 2/3 from path 1. Now we have to come up with a second path. So it's not always easy to find a second path. So you may try to come along the y-axis, say, and you might get the same answer again, 2/3. So finding the second path that gives you a different answer is not always easy. Okay, so for the second path here, I'm actually going to come along a parabola. So let me draw path 2. So path 2 then will be this parabola going through 1 minus 2. So 1 minus 2 will be the vertex of the parabola. Let's recall how to find write the equation of a parabola here. Let's first recall, so the equation of parabola with vertex hk opening up would be a times x minus h squared plus k, with a being bigger than 0. So we're going to apply that to our guy up here. Our vertex is 1 minus 2. So that'll be your h, and that'll be your k there. That's our h and that's our k then. So let's find out limit along path 2. So limit along path 2 would be y equals ax minus 1, because the h is 1 squared minus 2. So using our parabola formula here. Okay, so let me erase the parabola formula now and we'll keep going. Okay, so the limit x goes to 1. Because when x goes to 1, then y will be minus 2. You can check, because when you put 1 there, this will be 0. So this will become minus 2. So the limit x goes to 1. Then in place of the y up here, you'll be writing this. So that's what I've written here in place of the y. So that's my y. So they're both my y here and here. So simplifying this then, we get this. So the negative 2 and 2 would cancel there, so it's going to become 8a x minus 1 squared, and then 3x minus 1 squared plus a x minus 1 squared here. Let's factor out the x minus 1 squareds out of the top and bottom. So doing that we get this then. Then we can cross off the x minus 1 squareds here. Okay, so our answer then will become 2 plus 8a over 3 plus a. So we freedom over the choice of a here. If we chose a to be 0, I guess it would become 2/3, and that would be the same as the answer up here. But I can choose, say, a to be 1. So let's choose a to be 1. So letting a equal 1 then, you'll have then 2 plus 8 over 3 plus 1, which is 10 over 4, which reduces to 5/2. That's different than 2/3 up here. So our two different paths gave us two different answers. So therefore we can conclude the limit does not exist. So let me write that. So hence we can say limit does not exist at 1, negative 2. Again, because we got 5/2 for path 2, and up here at the top, for path 1, we got 2/3. So therefore we got two different answers coming along two different paths, coming into the same point, 1 minus 2. So hence limit does not exist. Okay, so let's leave the video there. We're actually done with 13.2 now. Okay, so let's leave it there.